Hello and welcome back to the channel. This is your host Castro. If this is your first time here, I'm a machine tool designer and builder by trade, and at the moment I'm working on quite a long-term project. I'm building a super precision DIY 5-axis machine in my own garage. And it's been a while since I have updated you guys. I've been quite busy, so apologies for not uploading videos. I've been working on the machine, but I also have some other projects that I've been working on. But it has come a long way since the last updates. So I wanted to show you a little bit more about what's been added to the machine. I've started, as you can see, doing some cabling. So the energy chains have been installed, and the sheet metal has arrived as well. Also the B-axis is, I can say now, almost done, so 99.9% finished. There's a couple of small bugs here and there that I'm sort of fine-tuning, and the C-axis is halfway through the build. So without further ado, I wanted to show you guys what has been added to the project. But beforehand, I want to show you a few parts that have been arrived by a company called JLCPCB. So these guys reached out to me some months ago, and they've got a service in China where they produce parts or prototyping, whether it's 3D printing or CNC machining. They can do small batches, big batches, and it's got quite a very intuitive website where you can just upload your files onto their website, and it gives you instant pricing for the type of different materials. So I ordered some parts to them, and they were kind enough to sponsor this video. So the parts have arrived. I want to unbox it in front of you guys, so it will be my first time seeing the parts as well. And we will just take some small measurements here and there to see the quality of the parts that have been arrived. So let me first show you those parts, and I also want to show you some of the cabling that I'm going to be using on this machine, which is particularly important, I think, for those who are considering using or creating something like this, a DIY CNC machine. The cabling is always a big issue. What type of cable, which brand, and what sort of cable you need to be using. So, but I'm getting ahead of myself. So let me reposition the camera and let's look at some of these parts that have arrived. Right, let's get into it. So, as I said, the company is called JLCPCB, and their website is jlcpcb.com. They print out circuit boards, and they've got a CNC machining facility as well. So let me start with the smaller one. This is a part that I didn't really need because I already made it out of CNC machining out of a piece of aluminium, but I ordered it anyway just to show you guys what can be achieved through this website. So I'm assuming because it's in a separate bag, this must be the 3D printed part. So let me just see. I ordered this one to be printed out of stainless steel. It's a very small part. This is for holding the one of the encoder, the linear axis encoder read heads. Yeah, that's the one. It's got quite a bit of weight to it. I will probably show you this part later on, the one that I actually machined out of aluminium, if I can show it to you, because it's quite tucked away inside the machine. But here's the 3D printed version. It's surprisingly good looking. Yeah, I mean, it's quite hefty. It's got a lot of weight to it. It's full stainless steel. I think even inside is completely full, so there's no network of there's no mesh. It's pretty sturdy and nice looking part. So I'm pretty happy with that. I probably need to just twirl a drill inside these holes to sort of clean them up a bit, but other than that, seems like a very nice looking part. Okay, let's get into the bigger box. So in this one there's quite a few parts. Right, okay, let's have a look at these parts. I mean, they have turned out beautiful. So, take a guess what this is. So this is for holding the pallets. So this is one of the 15 stations where the pallets for the C-axis pallets will sit on. I wanted to anodize this one. This is aluminium, 6061, and I wanted to anodize it out of a bit of a different color. Yeah, it looks like a beautifully machined part. Every edge has been deburred and looks really, really nice. So not very critical in terms of tolerances, this part, but it turned out to be very nice. Okay, this one, which I've managed to slightly put a mark when I was cutting it open somewhere. I can't see it actually now. Oh, it's just a small scratch there. So this is to so this will sit next, well, in front of the spindle, and then we've got a rotary actuator that will sit in here, and it gets bolted through these bolts, and then the rotary actuator will operate a swinging arm, which is this arm, that rotates 180 to 0 degrees, something like that. And this is to hold another actuator, which is a set of fingers, pneumatic, that will operate these two arms, like so. They open up and they close down, boop, boop. And these are stainless steel, these are not aluminium, these two. Again, beautifully machined, all deburred, bead blast finish on all of them. And you can actually choose your finishing on the website, which is, I found it particularly good. And yeah, so these are machined out of stainless steel, and they will basically clamp onto the pallets, and then we can lift it up and put it on the Z-axis. So these are the grippers. Then we get to these parts. So these are the parts that I will be using for the turning tool, sort of tool changing mechanism. So this is the tool magazine. So we've got 1, 2, 3, 4, 5 pockets. So 5 static tools will sit on here, and these clamps, they're used to sort of adjust the height of each of those tools, and so they will be sitting like that. And then this whole thing will sit on top of a linear actuator, a pneumatic linear actuator that brings these tools up and down. Then we've got this part, which is for mounting that linear actuator next to the B-axis. But I will show you these in detail when I get to install them. But yeah, I mean, I'll just bring my calipers and take a few measurements. None of these parts were actually that critical in terms of their sizing, but I don't think that there would be any issues really, because I mean this is 200, well, yeah, 200ths of a millimeter below the nominal size. Let's look at the bore. So the bore is slightly low, I think 400th of a millimeter below, or maybe 300th. Worst case scenario, I'll just put a reamer through them and bring them to size. This is probably slightly lower. Let me just clean this up. Oh, it's got actually loads of, I think it's after bead blasting, there's some stuff left in it. So I think after a proper cleaning, it would show a better result. One thing that was important is the thickness of this bad boy. So yeah, I mean 300 above the nominal size, which isn't a deal breaker at all. I think these were 7, so 500th of a millimeter above. So it's the tolerances, they do ask for tolerances. I don't think that what they do is like super tight tolerances, but so far they seem to be okay. Yeah. Okay, so that's the JLCPCB stuff. Now let me get the cables out and show you what we have. Okay, so when we get to the cabling issues, or cabling in choosing the right cable, there's a lot of options out there. I have been using these cables from a company called Igus. They are one of the best in the world, I would say. German company. The cables are also made in Germany, in-house, and the quality is just really, really good, and that's what you want from a good, reliable cable, because recabling and troubleshooting, especially when you've got one of these small lines or wires that is broken and disconnected, can be a nightmare. So what we have here is a few different cables. You can already see the B-axis in the corner of the on your screen. So this is already using a couple of cables from Igus. This is part of their Chain Flex series. So this is mainly for sorry for the background noise. So this is mainly for a cable chain system, but in this case, in this instance, the B-axis is stationary, so it's not moving. So we've got a couple of cables here. One is for the power, which has got 4 separate lines, so for U, V, W, and an earth. It's also shielded. And then we've got another one which has got quite a few different lines for the encoder and the temperature sensors. That one is inside the stator, and another one that I have installed as well. So we've got this cable for those purposes. On the other hand, for the C-axis, we've got a different cable which is part of their robot series. Now this is particularly interesting because this cable is you can actually twist it. So it's designed to be twisted, and it's used inside the wrist of the robots, the 6-axis robots. So the cable is always twisting in this way. And because the C-axis, in the C-axis we've got a swiveling mechanism for the cables, so the cables will get some sort of twist. I think this is capable of being twisted plus and minus 180 degrees, something like that. We won't be twisting it that much. For our case, is 0 to 90 degrees at most, but because it's going to be sort of twisted all the time, I didn't want to take any risks and go with any normal cable. So we've got a pair of these cables. One is with 4 separate wires, which is for the power of the servo motor for the C-axis, so UVW and the earthing. But one thing that is quite important is that these are shielded as well. So this is a super flexible cable, and then we've got another one which has got quite a few more lines, which is for the encoder, a bunch of sensors that we've got in there, some proximity sensors, and a few other bits and bobs, temperature sensors. So they all get communicated through and connected through these wires. So on this one, I think I can read it somewhere on the cable. So it's got it's 4 times 2 times 0.14. So what this means is that there are 4 pairs of 0.14 cables that are twisted together. So this is really good for like your encoder signals, plus 4 times 0.5. So, and there are 4 other lines which are 0.5 millimeter, so that's their area basically. The cross-section area is 0.5 square millimeter. So that's the second cable that we've got. Again, this one is also for the C-axis. Then we've got a bunch of other cables. Now for these ones, I probably could have used a budget brand. Probably didn't need to go with Igus, but because they sell you, or at least in the UK, they sell even to like even half a meter, so you don't need to buy a full spool of cable. So you can actually get them by meter, and you know that it's high quality. And when I did some comparison, the price is not that much different. But these guys use a lot more copper inside their cables. You can actually see it visibly. It looks a lot golder than any other cable that you can get. So I went for Igus for basically all of the cabling that I've got. So these are different sizes of cables that will be used inside the energy chains, and you can see they're all cut to length based on the different things that I want, and these are all from their Chain Flex series, so they are designed to be used inside an energy chain system. So they should be good. Now I want to strap the camera onto myself and show you a little bit more about the installation and what's been happening inside the machine. Okay, now as you can see, there's been some new changes and new additions to the machine. So now we have the energy chains mounted. So we've got one for the X-axis, another one for the Y-axis. The cables come from the center of the control cabinet. It's now covered by some temporary cardboard, so nothing can get into it, but I've already made a metal hood that will sit on top out of sheet metal. So these are, for example, this piece here is stainless steel, 2mm laser cut and then bent. It's got a protective cover on it, but that will be removed. So we've got some of the cables mounted, and also some of the hosing have been mounted as well. So this is the grease distribution system. So that's been all fully sort of hosed up and piped up, and so all of the hoses and everything is being connected now, which is good. And that this is our inlet, which will be sort of connected to a longer hose, and then to a pump that will sit inside the cavity inside the machine. So these are the cables that are for the servo motors. So we've got 3 of them here. One is for this axis, which is the Y-axis, and this is a Beckhoff servo motor with an absolute encoder, an absolute a single turn. I think it's 24 or 27 bits. I can't remember, but this is the best accurate, sort of the highest accuracy encoder that they provide and they offer. Then we've got this big old cable, which is for our spindle. We will have a smaller control cabinet box here, which is plastic. It's sitting somewhere in the corner. That will have some solenoid valves inside, a bank of them, so that we will not need to bring like 10 different pneumatic lines all the way down from the machine and feed them up to where they need to go. So we've got only one pneumatic line coming up here and into the manifold with different solenoid valves inside. And then we will have a bunch of EtherCAT cable, cards rather, that will be connected using an Ethernet cable, which is somewhere here. I've already, oh yeah, there it is. So this is a Cat8 cable, RJ45 socket that will be connected to the Ethernet or EtherCAT rather cards that we've got inside this small control box, so that we don't need to bring all of these different sensors and everything all the way back to the main control cabinet and sort of clutter up all of this space with loads and loads of different wires and cables. So everything will be connected into this main control, and everything is just connected using this little cable and a 24-volt that will be fed up and fed into the mini control cabinet, if you like, up here. And that's got a glass lid, so you can actually see what's happening inside. So this face will be covered up with a piece of stainless steel, which is somewhere in the corner now, and then you won't see anything inside. The main thing that has been installed now is all the 3 linear scales. So the Renishaw linear scales, one is down there, I hope you can see it, with the read head there, and then there's another one for the x-axis, another one for the z-axis. So those 3 have been installed, and I have measured the signal, and I can actually move the axis manually just by holding onto the ball screw and rotating it by 50 nanometer increments. So I can actually rotate the ball screw, and you can see the axis. Well, you can't see the axis moving, but the axis is actually moving by 50 nanometer increments. And the way to test the signal is by this little device, which is a Renishaw ADTA100. So this is basically gets connected to your laptop, and it's got a software, and on the other side you just connect your Renishaw linear scale, and then you can see the signal strength level, and you can see the position being displayed on the system. But I will make a dedicated episode about the Renishaw stuff once I get power onto these motors, so X, Y, and Z start moving. Then I will make an episode about the linear scales, because I think it's quite an important thing in this project. Then this piece has been installed. There's another one opposite this one. This is for the covering, and then there will be a piece of stainless steel that will be mounted onto this. These holes have been tapped with helicoil, and there is a helicoil spring now inside these. So these are M3 small screws. And then we've got the tub, and this is the sort of the coolant tank, the coolant drawer. So it's still a bit cluttered, but I'm still working on it, still a work in progress. Some of these hoses have been sort of finished up, and then the energy chains, I've had them installed. I installed them, but then I removed them because it would be easier to sort of feed the cables through them, like where they are now. So that's pretty much most of the stuff that have been added onto the machine. So next steps would be just feeding more hoses, more lines, more cables, and then closing this off and put that small control cabinet, putting the manifolds in. There's going to be a bank of solenoid valves here, and another one in the drawer on the side. The drawer is also here, the rails and everything. So I don't think I'm lacking any sort of major parts now. Even the tool changer mechanism, everything for that one has arrived. I've got everything in that big wooden box there. So the big wheel and everything, that has been arrived. So once I sort of finalize the cabling around the machine, that I can actually turn it on and start moving it, then I will be working on the tool changer mechanism on the other side, and then we will finish putting the sheet metal onto the machine, which should be relatively straightforward because everything has been laser cut, and so it should be pretty straightforward. But yeah, we're getting there. It's a bit slow, but as you can see, there's huge improvement and huge progress has happened. And so keep on liking the videos, and if you've got any questions, please comment them below. I tend to answer all questions that come through. And please consider subscribing to the channel, because it gives me a push and encourages me to make more videos for you guys. So I hope to catch you in the next one, and cheers.